Hello guys, I would like to show you some facts and some informations about Serapeum Sakkara. Saqqara is known mostly for a stepped pyramid of Djoser from 3rd dynasty, attributed to architect Imhotep. This place has significant meaning in religion, in power of ancient Egypt. You can see Apis bulls, the symbol of fertility for ancient Egyptians. There's a reason for it. This animal is very useful at agriculture. It's very powerful animal actually. It's even better than horse for some specific works. But also Ptah is connected with this place, the god from ancient Egypt, very powerful, also god of creativity, craftsmanship, and we'll find a connection between these things. You can see the view from top at the complex. It looks pretty industrial. What you think? Now it's a ruin. You can see that the entrance to Serapeum is close to the pyramid and looks like this. So we are going to talk about underground complex Serapeum, which is supposed to be some kind of necropolis. So it's meant to be a place where sacred bulls are buried. This is the entrance. You can see it's carved into limestone bedrock. Here you can see the ancient depiction of the main part of Serapeum, the corridor, and on the left and right side, not opposite each other, but there are these niches and this huge sarcophaguses from granite. You can see the dimensions of this corridor. I will try to model it in 3D, you will see it, and I didn't have the exact measurements in millimeters or something, but you will see it will be enough for this proof that I'm gonna make. You can see some old pictures from inside. There is not so much space, you can see it. Check the quality of the walls. This is maybe a deck of or lid or of the sarcophag. It's from granite. That means it's not from this location, it's from somewhere else, probably from Aswan. On this picture you can see these huge sarcophaguses. They're estimated. You can try to calculate it. The granite has some specific attributes. It's very heavy. It's very dense. It's really something. It's a really good material to survive millenniums of years. This is the reason why it was used. Check the quality of manufacturing, check the overall design, and compare it to the design of interior walls of Serapeum, and there is a difference. So this is not consistent, the quality of this work, with the quality of the walls. So you need to know is this box was cut from one piece of granite, and it also had some special reason. But considering this, you have to realize that how much weight actually it has. So you can make some calculation. The granite is very dense, but let's start analyze how, not how it was manufactured, but how it was actually installed in Serapeum. You can see this name Canvaset, and it is a supposed creator of Serapeum. Okay, we need to move 1 ton box. It's this much car. It's not something very easy to move. If you have car that weighs like 1,350 kilograms, it will be this much. And just imagine the problems that you will have moving this object. Well, I need to tell you that I realized one thing. If you want to explain something or change the mind of maybe Egyptologist, you need to use their weapons. So we need to find a way how it could be done by means that Egyptologists say that it was done, or Egyptologists say that ancient Egyptians was moving the heavy things. We can see here the famous depiction of moving of like 58 tons alabaster statue, and there is depicted like 170, I don't know how many people, maybe 180 people moving the statue, okay, with ropes. This guy in the middle is pouring something to make the coefficient of friction lower, so these slides or the sledges are moving easier. So in our problems with 70, 80 or 100 ton box is we need this much people. It's a lot of people. It's like 300 people, maybe more. Here's the equivalent in oxens. So let's try to find out how it can be done. Let's go inside. okay, here we are inside, and let's try to use wood to make it possible these boxes fitted inside niches. I've calculated the biggest dimensions of such timber, like 30 per 30 centimeters is like 12 inches per 12 inches. It's questionable with wood in Egypt. They could have some cedar trees from Lebanon, some imported wood. So okay, I've considered this the strong wood in in the calculations, but you have to know that if you add this this is like 2.5 meter or 2 meters. If you add a lot of this in a row, the capacity of such element is reduced significantly, so it will start bending and all these other things. Okay, here are the calculations. It's a standard thing. You can see that 12 per 12 inches can have capacity of 100,027 pounds, which is quite a lot, but you have to remember it's only 2.5 meters. So when considering something long, you have to keep in mind that the capacity is reduced significantly. You can see that at the 30 meters, which is 100 feet, it will weigh already 2 tons, 30 per 30 centimeters, and the capacity is only 4,000 pounds. So it's not enough. We would need maybe 20 of them, and there is no space for that. As you can see, with wood, it's like either it's long enough, either has capacity enough, or either there is enough people working. Not all these things together, so it's not possible. But let's watch it. Okay, this is the thing that okay, this device probably wouldn't bend, you know, and you could make really that force with it that you need with an enormous amount of people. Maybe you can see here maybe 300 people or something more, but this is the problem. It will weigh like 72 tons more, so it's like you have to push another box, so you basically didn't solve any problems with a device like this, so this is not good. This is just wrong. Another thing is you can see here with the short timbers, I was calculating maybe 4.5 meters, I think, something like that. You can have like 36 people working, but which would be enough capacity, but not enough people working, even if you have 2 or 3 groups like this working. Okay, and there is no place for more groups. Ropes. So why don't we use horses to do the hard work? You can see here horse pulling. In the back you see the blocks waiting. I mean, these 2 horses can carry several of these blocks. It could be around something maybe ton, or even maybe more than a ton. So ropes, bollard, and friction. That's the thing that we're gonna concentrate now. We can easily dimension such a rope. Not easily, but we can do it. You see the mechanism of calculation. For example, we would need 5 ropes of 13 centimeters diameter, or 1 rope 29 centimeters diameter for safely to work with such an object. and also the each 1 meter of rope is gonna weigh only like 35 kilograms, so it's not that bad as a wood. But there's a problem something else, somewhere else. Okay, here you can see the coefficient of frictions, different materials. You can see hemp rope, timber. You can see horseshoe concrete. So don't forget also these horses, as you saw on the pictures. They had some problems with friction. So basically, it's easy to calculate, but also it's good to use empiric, calculation. For example, also Wikipedia, and also then that depiction of Egyptians are showing us something around. Really, that we would need like 300 people for considering all these friction problems, 300 people for dragging this thing. So again, outside it's another problem. We are inside, we are underground, and the problems are starting. So even with bollards, okay, this is not with bollards. So this is the normal situation. A lot of people, some people would be pushing, some people would be pulling. Okay, they can make it at maybe this point, but don't forget you need to make a turn and put it into niche. So this is the problem. This is the problem, and they just cannot do it just by pulling or pushing. Okay, and there's also a problem with the quantity. You can see lots of ropes. It's known from the lifts, where you have to not just calculate when it breaks, but also make a safe calculation so it's not breaking. You don't want to break this thing and break the rope and break the sarcophagus. Okay, this is the bollards. So this is the only system that can be used here that Egyptians maybe knew, and a lot of people would be applied to work. But there is the friction problem. Yeah, you can see it. Even this size of rope is underestimated. Okay, so this size of rope is just for pulling, not for the bollard. With one bollard, it would be even bigger. But it would be possible. With one bollard, it would be possible, but not with two. We'll see in the calculation. So with one bollard, you cannot make it turn into the niches. Okay, the calculation. You can see very easy mathematics. T load, the force equals T hold multiplied by exponential of coefficient of friction and the angle. So the angle, if you have it like on a picture, it's p radians, something around 3. Okay, and friction. This is complicated. It can be 0.2. I think it would be much more. So I have calculated that with 2 bollards we would need 6 times more people, and there is of course no place for them. So it's not possible to use bollards in this case. It's a really easy calculation, and you can try it each time you apply a bollard, the force rises like very much exponentially. So this is something that cannot be done by using bollards, even if Egyptians could use them. Even if the rope would have also 6 times more, dimensions of section of the rope. Okay, how about levers? You can see this is the ancient device that is used for lots of things around the world. And when we're gonna apply it in our case, we'll see that if we put some weight, 1 ton, on here on the left side, and the car, like heavy car, on the other side, yeah, it could work. It could work like this. And actually there are some people, you will see the link, that were trying to use this method for calculating how the Great Pyramid could be built. But again, we see that we would need, I think, 70s of them. And for this much, I mean, even if we if we would need, I mean, 50 of them, it doesn't matter, because there is no place. You can see we are underground, and lever just need space. That's point of a lever. So we cannot use levers underground because there is no space for this. I'm sorry. At first I didn't want to even mention this, but okay, let's do it. Ancient Egyptians didn't use pulleys. However, there are some people who were inventing the pulleys. You'll see the link, with a stone device like this. And you know, they are lowering the friction coefficient by this, but you know, if you think about it, it's not it cannot be used here. So what's the story about pulleys? I'm here consistent with mainstream Egyptologists. For example, if you check this book, Ancient Egyptian Masonry, on page 44 and 45, logically those authors are assuming that ancient Egyptians just didn't know pulleys. They cannot found it on a preserved bows, where using of such device would be very useful. And they didn't it's not found in the ruins of buildings. They just didn't use it because they didn't have material strong enough. Bronze is not good for that, for such a weight. Okay, so no pulleys. Okay, so let's make some summary of this. I'm trying to move fast here in this video version, because don't want you to be bored. But if you think about it, you have to think about it this way. It's not possible to position these boxes inside niches. You cannot say it would be enormous effort or something like that. Yeah, it would be enormous effort to bring these grind boxes inside Serapeum, but it can be done. They did it. Outside it's not problem, but this is the point. Positioning inside niches, last few meters of track of each box is not possible. So if I'm challenging you to propose a way of doing so, but I can model it. It's fun for me, and I'll do it, but I don't think so. Yeah, safety first, but I want to say that let's have a look about wider context. So let's put this calculation, these things that I made, let's put it in a wider context, and let's see what we can get out of it. You can just, the rest of the presentation, you can just read it for yourself as a book. So here is Apis bull, and here we have a ptah, two symbolics that we will find a connection between. And we need to know that it's all about Ramses, all about his power. He was the greatest one, considered to be a great ancestor, really the best ruler of ancient Egypt. and you can see here his depiction of fighting different nation, Hittites, Syrians, later you will see Nubians, and all this was then put on these victories were exaggerated, okay, and even lies, straight lies, were shown on these depictions about this, and this is something that mainstream Egyptologists are familiar with. Okay, so it's normal. It's normal. It's like the same thing that our politicians do. Okay, so I'm telling it to you because you need to know this context, considering his son Kaimeset, suppose that builder of Serapeum, that in those times, in any times, it's normal to do so